Hello students, welcome to Spectra Education Academy. In this video, I am going to explain the answers for remaining questions in the chapter Electric Field and Charges. So let us continue with question number 4. Question is, derive an expression for the intensity of electric field at a point on the axial line of the dipole. So first, you remember intensity of electric field at a given point is 1 by 4 pi epsilon naught q by r square. So r is the distance from the respective charge. So this you need to remember. So first thing is, what is axial line? So axial line means first you draw the dipole. So this is positive charge of the dipole. This is the negative charge of the dipole. And the line which is passing through. Line which is passing through both positive and negative charge of the dipole. So it is just like principal axis in case of mirrors, spherical mirrors and lenses. So therefore, this is considered as axial line and which also passes through the center of the dipole. So this is center of the dipole. Now, as per the question, we need to select a point here. This is point P. From the center of the dipole, distance of point P is R, whereas dipole length is 2a. So that 2a can be split into a and a. So from the negative charge to center is a, and similarly from the positive charge to center is a. So altogether this is going to be 2a. So 2a is the dipole length. So this is positive charge, this is negative charge. So based on the diagram, we need to write the sentences. Consider a dipole of dipole moment P. Dipole moment P. Let P be a point. P be a point at a distance R from the center of the dipole. Now let us write intensity of electric field due to positive charge. First let us complete negative charge because negative charge is closer to point B. So this is intensity of electric field. Intensity of electric field at P due to negative charge. So keep this equation in mind. So what is R here? R is the distance from the respective charge. Now, so intensity of electric field from the negative charge, but point P is at a distance. It is at a distance r minus, because this part you need to subtract. This A part you need to subtract to get the distance from negative charge to point P. So this is going to be r minus A. Whereas from the positive charge, this P is located at a distance of r plus A. So therefore, intensity of electric field due to negative charge is 1 by 4 pi epsilon naught q by magnitude of charge is same. So therefore, distance from the negative charge to P is r minus A. But in the basic equation there is square, so you need to write r minus A whole square. Similarly, intensity of electric field due to positive charge. This is intensity of electric field. Due to positive charge. So where is positive charge from P means it is at r plus A, because this is r plus A. So you have to modify the basic equation. In this case, intensity of electric field due to positive charge is 1 by 4 pi epsilon naught q by r plus A whole square. Now look at in the diagram. In general, electric field lines starts at positive charge. starts at positive charge, they are crossing and moving away from point P. So this is the direction of intensity of electric field due to positive charge. Same way, electric field lines move towards the negative charge, crossing point P, moving towards negative charge. So the directions of the fields are opposite. So when two vectors are opposite, so according to parallelogram, a square plus b square plus 2ab cos theta, theta will be, so angle between these two directions, theta will be 180. When theta is 180, parallelogram turns as C equal to A minus B. So C is the resultant vector. Same way, resultant electric field intensity at point P. So since magnitude of negative charge at P is greater, so therefore we write this is a net electric field. We write negative charge Q because it is closer. Its field intensity will be more at the nearer point plus Q. Yeah, so we got the equations. 1 by 4 pi epsilon naught Q by R minus A whole square, that is for negative charge, minus 1 by 4 pi epsilon naught Q by R plus A whole square. Now take out common 1 by 4 pi epsilon naught even Q. So you'll get that R minus A whole square and R plus A whole square. So at the numerator you'll get that. So taking LCM, so you'll get R plus A whole square minus R minus A whole square. So continuation, 1 by 4 pi epsilon naught. So expanding this, R square plus A square, it is like A plus B whole square, 2RA minus, this is going to be R square plus A square minus 2RA whole divided by, let us write this equation as, because R minus A whole square means 2 times you can write R minus A into R minus A. Similarly, there is square also for R plus A. So you can write 2 times R plus A into R plus A. R minus A into R plus A. Even what you can write is 1 by 4 pi epsilon naught Q by. So R square plus A square plus 2RA minus R square minus A square plus 2RA divided by, you can write R minus A into R plus A as A minus B into A plus B as R square minus A square. Similarly, there is this one and this one. So that also you can write R square minus A square. Yeah. Next, you can continue this step as R square and R square get cancelled. A square and A square get cancelled. So 2RA plus 2RA along with 1 by 4 pi epsilon naught and Q. 2RA will be 4RA. At the denominator it is R square minus A square whole square. So you can split 4RA as 1 by 4 pi epsilon naught Q into, from this to 4RA you write 2A because this is dipole moment. Remaining will be 2R divided by. So this can be R square minus A square whole square. So this can be written as 1 by 4 pi epsilon naught. This is dipole moment, 2A into Q is dipole moment along with 2R divided by A square divided by R square minus A square whole square. So even you can give unit vector also because electric field intensity is a vector quantity. So in case if it is short dipole means distance from the negative and positive charge of the dipole is very less compared to the distance from the center to P. So R greater than E. So you can write E net is equal to, this is all E net only, 1 by 4 pi epsilon naught P into 2R divided by, you are neglecting A means you'll get R cube, R to the power of 4. So with the R cap is the unit vector along which electric field acts. So one R get cancelled, you retain with the R cube. So therefore final expression is 1 by 4 pi epsilon naught 2P by R cube with R cap. Yeah, so let us continue with the next question. So previous question was along axial line. Now let us continue for equatorial line, intensity of electric field. First you draw the diagram. This is once again positive charge of the dipole. This is negative charge of the dipole. Now the distance between positive and negative charge is called a dipole length. So that you can split as A into A. It is 2A actually, but you can split as A into A. A into A. Now the line which is perpendicular to axial line, because you said this is axial line which is perpendicular to axial line passing through the center of the dipole is called equatorial line. On equatorial line, you are choosing a point P. This P is at a distance of, this you said A, you call this R. So this will be hypotenuse. According to Pythagoras principle, you can write R square plus A square. Then same way, electric field lines are starting from positive charge, going away, crossing point B. Same way, electric field lines are moving towards negative charge, coming towards negative charge. So if you give tangent, that shows the direction of electric field intensity due to negative charge. Same way, field lines are starting and going away from point P. This is intensity of electric field due to positive charge. Now, so once again, and this is also same distance, because from point P to negative charge is also same distance, that is hypotenuse, R square plus A square root. Now consider once again, consider a dipole of dipole moment P. Let P be a point, at a distance R from the center of the dipole, along the equatorial line. Now, so there are two things here. First, let us write intensity of electric field. Remember basic equation of intensity of electric field. So this is the final answer for question number 2, Q by R square. So intensity of electric field due to positive charge first at point P. So therefore, 1 by 4 pi epsilon naught Q by. Actually, in the basic formula, it is R square. But what is the distance between point P and positive charge? Here is root over R square plus A square. This is R distance, but in the formula, this is R square. So you'll get 1 by 4 pi epsilon naught Q by R square plus A square, because square and root get cancelled. Same way, intensity of electric field due to negative charge. 1 by 4 pi epsilon naught, because point P is at equal distance from both negative and positive charge of the dipole. So therefore, for negative charge also get the same equation, R square plus A square without root. Now the basic thing is, here there will be two components for the fields due to positive and negative charge. So here itself I am trying. This is the along this direction net field act. So once again I am drawing here. So this is the direction of intensity due to positive charge. This is the direction intensity due to negative charge. Both these fields are not exactly acting along x-axis and y-axis. This is supposed to be x-axis. This is supposed to be y-axis. So therefore, E plus Q, E is a vector quantity, is falling in positive y and positive x direction, whereas E due to negative charge is falling positive x and negative y. So if you give theta here, using a resolution concept, you can write this is E plus Q sine theta. So component of electric field of due to positive charge. If you give theta here, there will be component of even negative charge, the field due to negative charge. This is E minus Q sine theta. Since magnitude of both the E plus Q sine theta and E minus Q sine theta same, acting in opposite directions. So E plus Q So intensity of electric component of intensity of electric field due to positive charge is equal to component of electric field due to negative charge are equal in magnitude and opposite, they cancel. They cancel. So whereas there are other components, because once we say that component of E plus Q is E plus Q cos theta. Same way, because this is E minus Q is acting in the plane positive X and negative Y. So even E minus Q also will have its component which is joined with component of electric field due to positive charge. So therefore, E net is equal to E due to positive charge, component of E due to positive charge, plus component of U due to negative charge. But magnitude part, E plus Q is equal to E minus Q because magnitude of the charge is same. Now, so let us call this as E only. Now joining the same quantities, you'll get E net as 2E cos theta. So E equation is this. Anyone is can be E. So therefore 2 into 1 by 4 by epsilon naught Q by R square plus A square. Now coming to the cos theta part. Cos theta you can say this is right angle triangle. Once if you give theta here, this can be theta. Cos theta means adjacent by hypotenuse. So adjacent is A in the diagram. Hypotenuse is R square plus A square with root. This term is without root same, but this term is with root. So you can finally write 2 of 1 by 4 by epsilon naught. This is 1 plus 1 by 2. Root means this is going to be R square plus A square as R square plus A square to the power of 1 by 2. Bases are same, powers are added. R square plus A square to the power of 3 by 2 along with E. 2QA is again the equation of the dipole moment. 2A into Q you can write. So this can be 4 pi epsilon naught R square plus A square to the power of 3 by 2. This we can write 1 by 4 pi epsilon naught P by R square plus A square to the power of 3 by 2. For short dipole, R A is less than R. So therefore, keeping that in mind, we can rewrite this equation as 1 by 4 pi epsilon naught P by R square of 3 by 2. So therefore, final equation is 1 by 4 pi epsilon naught P by R cube. So P is the unit vector you can say. This is the final desired equation. Yeah. Let us continue with the next question. State Gauss law in electrostatic. Explain its importance. Yeah, let us continue with the answer. Statement we need to write first. The total electric flux. So it is represented as a pi. The total electric flux through any closed surface is equal to, because this is a mathematical part. So using mathematical part, you can write the statement. Net charge 1 by epsilon naught times the net charge enclosed. Otherwise, you can write this is epsilon naught as Q. Now, statement is the total electric flux. The total electric flux through any closed surface. Any closed surface is equal to 1 by epsilon naught times 1 by epsilon naught times the net charge enclosed by the surface. So it means outside, suppose if this is the boundary, we always consider the charges enclosed by this boundary. If charges are available outside, we don't consider it. So this is what the meaning of statement, Gauss law statement. Now where epsilon naught is permittivity of free space. Now coming to the importance. To determine the intensity of complex configuration of charges. To determine the electric field intensity. Electric field intensity for complex form of complex configuration of charges. Complex configuration of charges, we use Gauss theorem. We use Gauss theorem. So we cannot apply Coulomb's law for the determination of electric field intensity. Next, the second. This is first one. Second one. So Gauss theorem can be applied. Gauss theorem can be applied to determine electric field due to a stationary charge as well as charge which is in motion. Electric field due to a stationary charge, also when charge is in motion. It means electric field due to charge in motion also we can find out. Also when charge is in motion, so its electric field intensity also can be determined. Next, third. Gauss law holds good. Gauss law holds good for any closed surface of any shape. Holds good. Charges enclosed by any closed surface of any shape. Holds good. Charges enclosed by closed surface of any shape. And last, Gauss law gives a relation between electric field and charge. So thank you very much, students, for watching my video. In the next video, I'll continue with the explanation for short answer type questions from potential and capacitance. Once again, thank you very much for watching. But don't forget to share and subscribe with your friends and relatives.